Okay, so by now you should have a working model that consists of a few items. There's your working surface, which is this. You should have some kind of slope mesh to show the different slope gradients. You should have some contour lines, as well as some drainage lines. These are all going to be used to help determine our stormwater runoff volume within their respective areas. So I'm going to go ahead and start with the surface. I'm going to turn off the slope so I have this to be a little bit more legible. So the first thing we need to do is divide this into the respective sub-drainage areas or watersheds based off of the drainage lines and the ridge lines that are from this. So the first thing I'm going to do is I'm going to actually take this surface and copy it. I'm going to be splitting this into their different regions. So I'm going to do copy in place. I'm going to create a new layer and title this drainage areas. Okay. I'm going to now, with that surface still selected, I'm going to change that layer to drainage areas. Now I'll turn off surface. Nothing should really change because you simply made a copy of that and turned off the duplicate. So now we're going to use this to split into those regions by drawing some ridge lines. So with this selected, I'm going to go over here and choose the Interpolate on Surface tool. It's going to ask me to have a surface selected if not so already. Now I'm going to start at the edge of the surface and start to use the contour lines and drainage lines to determine where that ridge line is going to be. So starting at around here, again, we know that there's water flowing this way and that way, as well as the contours helping us define this edge. So it doesn't have to be exact, but it should do well in terms of dividing the surface evenly between the drainage areas. So we're going to just draw this here. We can see that there's that drainage area that goes there, so we want to make sure that that stays on that side. And I'm just going to follow this all the way down till about there. That looks good. So I'm going to actually create a new layer with this. I'm going to also create a layer called Ridge Line. Make that the active layer, give that a different color. Make sure that that is selected on the ridge line. You can see it's there. It's a little faint with that color, but now we can take this surface and split it with that ridge line curve. So I'm going to select my surface, type split, heading objects, that's our ridge line curve, hit enter. Now you can see when I select the surface, there's one ridge line or one drainage area, and there's the other drainage area. That's exactly what we want. So now we can turn off our contours as well as our drainage lines because we don't really need those for the remaining part of this. So I'm going to go ahead and change this to shaded to help clear this up. We also don't need our ridge lines selected, but we are going to use our soil types next. As the assignment states, we need to have two different soil types. There's a soil profile within this curve, and then there's a soil profile within that curve. Each one of those regions needs to be separated into those respective types. So I'm going to select that soil type layer, create some sublayers. This will be sandy loam, and then the other one's going to be clay, because that's the different types of soil that are used for this calculator. I'm going to now split each one of these areas by their soil profile curves. So I'm going to just start with this one first. Type split again. Type the cutting objects, that's again these curves. So now you can see I have those different soil type regions. And I'm going to do the same thing for this side. So if I hit space, it'll just repeat that command, select that curve. So again, now we have our different soil types. We're going to use these ones to be our sandy loam. So let's go ahead and change that to sandy loam. Change that color. Yeah, it's an orange. And then this other soil type for clay is going to be, more of a reddish or a brown color. Now with those selected, I can go ahead and place those on their respective layers. So there you go, there's our different soil types. Now the next thing we need to do is also determine where are the different land cover types or vegetation cover. Again, the assignment asks for 2 different types. So we need to use our drawn vegetation cover lines to divide these surfaces even more. I'm going to work one soil type at a time just because it's going to get a little hectic there. So I'm just going to first split up my sandy loam by the vegetation cover. So this closed curve is my vegetation or my forested area, as well as over here, and then the rest is going to be considered pasture or grassland. So now I want to create some sublayers for that. This one's going to be forest sandy loam, and then the other one's going to be grass sandy loam. And again, the reason we want to divide these is because they have different coefficient values within the calculator. So that's why we need to subdivide the soil types into also their soil type / vegetation cover, because they're going to be slightly different variables which will impact the runoff volume. So like I said, I'm working with just the sandy loam soil profile, and I'm going to determine which parts of that sandy loam is in the forest versus what's in the grass. So these large open areas are considered grass, and these closed ones are forest. So let's go ahead and do that. And again, I'm going to start with one subregion or drainage area at a time. So I'm going to go select those, type split, select my curves. In this case, I don't need any of that because none of those are intersecting. Okay, so now I have this part that's part of inside of that forest, as well as this part's also in that forest. So this will be my forest sandy loam. So let's give that a different color. Oop, and this one's also in the forest sandy loam. Okay, so now the remaining parts of this region are grass sandy loam. And again, I'm going to give that a different color. Okay, so there, you can start to see how that profile gets a little bit different. So I'm going to do the same thing over here. I'm going to select the surface, type split, select the curve that I want to use to split it. So now I have here is forest sandy loam, and this is also forest sandy loam. And then these remaining parts are the grass sandy loam. Great. So now I can go ahead and turn off of those layers and then turn this layer on and do the same thing. This, now it's going to be forest clay, and forest sandy, sorry, grass clay. So again, we're going to work with one at a time. So let's go ahead and select these curves. So I'm going to set my surface here, type split, select that closed curve. So now I know this is in the forested area as well as this. So this is my forest clay. Let's give that a different color. And these remaining parts are my grass clay. Now we'll do the same thing for this last area. Let's type split. Select this curve to split it. So we need to split it over that curve as well. Okay, so this looks like it's the only part in the forest, so that's my only forest clay area. And the rest is grass clay. So now I can go ahead and turn all these off. I can turn off the soil type. Now we can see there's 4 different classifications for our surface type. There's the forest in the sandy loam, forest in the clay, there's grass in the sandy loam, and then grass in the clay soil type. So 4 distinct surface types. We're going to use these for our calculator now. So now that we've got our surface nicely divided into their different classifications, we can start to assign their coefficient values for our runoff event. So let's go ahead and start grasshopper. Spell that right first. Okay. So now we can start to determine our runoff volume. So I'm going to start off, because we're going to have 2 different drainage areas, I'm going to do just one of these drainage areas and then just show you how you can easily copy the script and apply it for the new drainage area. So I'm just going to label this drainage area 1. And I'm going to work with, again, just this side. So I'm going to actually go ahead and select all these surfaces on the other side and type hide, because it'll be easier just to work with one at a time, as well as having it only showing one at a time. So again, this is drainage area 1. The first surface type we're going to work with is the forest sandy loam. So let's go ahead and create a surface. Rename this forest sandy loam. Now it's nice. I can just go over to my layers, right click, say select objects. So you can see they're selected in there. Say set multiple surfaces. So there, now I have those referenced. I'm going to go ahead and turn that off. If we look at our textbook or the notes, we'll see that there's a certain coefficient value for that. Let me refer to my book as well at the moment. So again, for that woodland or forest sandy loam, that coefficient is going to be anywhere between 0.1, 0.25, or 0.3. We can't determine that until we actually know what that slope percentage is of each one of these surface types. The best way to do that is to find In this case, the average. We could do something much more detailed about looking at all the different types of surface conditions here, but for the purposes of this assignment, we're just going to find the average for each one of those sections. So there's 3 right there. You can see that there's 3 reference surfaces. So what we need to do is convert these to a mesh. We're going to deconstruct this mesh so we can see what all these vertice points are on here to determine our slope. And similar to what we've done in the last exercise of determining slope percentages, we're going to compare these point directions with a z direction to find that angle of the slope. So let's go ahead and turn this off as well. You can take a z vector to compare. I'm going to go ahead and select one of these just to make sure it's pointing in the right direction. So you can see it's pointing up. That's good. So I'm going to go ahead and find out the angle for that, for all those points with this one. I'm going to convert that to slope percentage. So go to trig, tangent of that, multiply it by 100. So that'll give us our slope percentage. And what's nice is if I go ahead and grab this, and look, we can see that there's 3 sets of lists. This one is looking at one of those surface types, and then when the numbers start again, it's looking at the next surface type, and then lastly there's that 3rd surface type. So we're going to look at the average for each one of those. So let's go ahead and keep that around. Let's go back to math, utilities, average. So I'll drag that into there and drag it into here. So there you go. Now we have our average slope percentages for each one of those regions corresponding. So there's the 3 slope percentages and their corresponding surface types. So now that we have our slope percentages, we can actually determine their coefficient values based off of that. So we know that by looking at our book, we know that a flat area, so 5.1, that's pretty flat according to this calculator, for sandy loam is 0.10. And then the 12 to 16, that's all within the same parameters of a hilly area. So these are going to be 0.30. This is also going to be 0.30. So we can go ahead and remove this. This is really just to help us find that parameters. So according to the calculator, we need to know that coefficient values, that's these. So let's go ahead and move those over here and say coefficient values. Oops. We need to know the coefficient values, the precipitation intensity or rainfall intensity. So I'm going to again create a label for that. And we know for the specific assignment we need 0.52 for our rainfall intensity, but by keeping that as a slider, we can look at other different rainfall intensities as well. So there's our I. So if it helps, you can always give it that initial for the calculator as a reference. And then lastly, we have the area, which is needed. So an acre. So what's nice is with those service types, we can easily find that area by typing area. We'll see that these are in square feet, but we need them in actual acres. So I'm going to drag this over here and do a small conversion. I'm going to right click on this G just to go to my wire display and choose hidden so it's not creating a lot of overlap. I'm also going to go ahead and graph this so that they're separate types just like that. So I'm going to go ahead and divide these values by 43,560. That is the square footage of an acre. So now we have values for acres. And if I, again, grab one of these tabs, you can see what the values are for those. My units are set to only 2 decimals, so that's why it's showing that as 0. If I go to wire preferences, decimals, and change that to maybe 4 for now, and then just relink that, we can see the actual acreage. So what's nice, I can now take those values and multiply them all together. What I want to do is go to Math, Multiply, and I want to multiply these values. So I'm going to hold Shift to add that plus sign to drag them all into there. I'm going to choose Graphed as well, so now we'll see that they have their own list items, as well as this. And that way, that data stays within their own data set. So this is those values multiplied. And now we can take that value and multiply it by our rainfall intensity. So if you want, you could move this over here, move these parts because they're getting multiplied first, and this is multiplied last. This is just because of the way the data is being organized. It's easier this way. I'm going to go ahead and turn off this so I don't have those boxes. And so again, this is giving us a Q value, or cubic feet per second. For this assignment, we don't really need to know what the flow rate is or that Q value. We actually need to know runoff volume. So the way you do that is you multiply this peak flow runoff by the length of your rain event in seconds. So if this is a 1 hour event, that means it's going to be 60 times, so 1 hour, 60 minutes times 60 seconds gives us 3,600. And again, you can have it as this hard value, or you can make a slider, so 3,600. That way, if your rain event, if you change it to maybe be a 2-hour rain event or a 30-minute rain event, you can always change that value. But for now, I'm just going to keep this tab. So now I can multiply this Q value, or peak flow runoff rate, by this. And now I have runoff volume in cubic feet. So there you go. What's nice is that even if you've kind of takes a little bit of time with that, you can simply copy and paste these change your surface type. So in this case, we're going to do now grass, sandy loam. We're going to go to Rhino and say grass, sandy loam. So select objects, set multiple surfaces. What's nice is now we just have to change our coefficient values based off that slope. So let's go ahead and move these over. So again, so now we look at our table again for our soil texture for sandy loam and a pasture or grass or lawn. We can see this one's considered flat. So we'll go ahead and also add another one. So this one has a sandy loam pasture flat, has still 0.10. 26, that's pretty high, so we'll change that to 0.22. That has between 10 and 30%, so that's considered hilly. 32, again, that's going to be 0.22. And then this last one, 11.32. That's going to be considered rolling, so 0.16. Okay. And what's nice now is I can go ahead and just add this into there. We can see that this is still looking at all 4 different surface types. It's going ahead and multiplying those together. Rain intensity is the same with that. And now we have our new runoff volumes, which is great. So you can see we didn't have to change a whole lot in order to get those new results. So all you're going to do is simply copy and paste this 2 more times for the clay soil type. Re-reference those layers from your model. So you're going to change that to forest clay. This one's now going to be forest or grass clay. Use that chart to determine the new coefficient values based off the slope percentage. Then you'll get those new runoff volumes, and once you do that, we'll just leave it there. The next assignment, we'll go over how do we start to visualize these runoff volumes. And what's nice is, again, I can just simply copy and paste this quadrant of scripts, move it down there, and this becomes our drainage area 2. Hit OK. And type in here show. Then select the V's type. Type hide. Let's get all of them. Now do the same thing. Reference them by their condition. And re-reference them, and then you'll have your runoff volume. Pretty efficient once you get that first script done. So go ahead and apply this, and we will use the next lab session to begin to visualize these runoff volumes.